Okay, folks, so we're ready for our next talk. I'd like to introduce Tereza, who is going to give us a talk on lessons learned from teaching data science. Take it away.
Yeah. So, hello everybody. Thank you for being here at my talk, and thank you, Nick, for the introduction. So today I'll be talking about how to successfully become a data scientist from lessons learned by teaching data science. So I would like to ask, anybody who here is a data scientist already to stand up a little bit. Don't raise your hand, stand up, Anybody a data scientist? What about an aspiring data scientist? It's good to do some sports, stand up, yeah, that's really good. Okay, who here has worked in a company that has data and data teams? Good, stand up, not just raise your hands, it's good, like a little bit of movement. Okay, thank you, that's a lot of people. Okay, cool. So, during this talk, I will ask, so there were a lot of people that know data and know data people. So I would like to ask you to contribute to this talk by filling in a survey of answering one question. You can use your smartphone, scan the QR code, and the QR code will appear on the next slides as well. Yeah? So the question that I'm asking is, which skills did you notice in data people you actually enjoyed working with? Right? So not skills you want to have, but skills that you've noticed in people that you enjoyed working with. Okay, you see people still scanning. Cool. Okay, so let's start talking a bit about the definition of a data scientist. As a profession, it's fairly new since 2008 when DJ Patel and Jeff Hammerbacher, who were working at LinkedIn and Facebook, they made it into a buzzword as a profession. And they were looking for a job title that was didn't sound too Wall Street-like, so that would have been a data analyst, and didn't also sound too academic. And they kind of come up with this definition, and their deliberate reason behind the definition was to make it sound sophisticated and vague, so that nobody knows what a data scientist is doing, but everybody wants one. Yeah? So even the people that have no idea about data, they do want to hire a data scientist. So that was the goal, right? So which basically transformed the field of data science into this, how do I become a unicorn field? I have to be able to do everything, anything, all the time. Yeah? But there is another definition for data science, which is a little bit older. It's from 1974. Peter Naur wrote it in a report called the Concise Survey of Computer Methods. And here we see that one keyword that I like is usefulness. So it really focused on bringing value and being useful to, and not just being vague, hype, and sophisticated. So what does that mean? You see the unicorn sign is gone. We do not want to become a unicorn anymore. We want to become just a little horsey, a pony, whatever your kind of horse you like. And anybody here has these t-shirts with if you can be a unicorn, then be a unicorn, an amazing unicorn? Yeah, we don't want those t-shirts either in data science, yeah, so don't get those. Okay, so do not forget about the survey. If you did not scan it, this is another moment you could scan for the survey. And a little bit about me. Why am I talking about this? Yeah. So this is a picture from one of the diversity and inclusion meetings of the Python Software Foundation. But otherwise, so I'm doing a lot of volunteering, a lot of community work, and otherwise I'm working as a head of data science at a bootcamp school where we are helping people change their careers. I'm also doing leadership coaching for data people and organizer of PyLadies Hamburg. And I'm a board member of Python Software Foundation, Verband in Germany. So anyway, I'm doing a lot of things, and artsy stuff, you know, of course, because who doesn't do art? Okay, so from teaching in the past 3 years data science to a lot of people, I've noticed that there are, and actually I also worked in data. I was a team lead, I was a data scientist, I was a data product owner, I was a data engineer, so I've been all around the spectrum of like, and I was also in academia, I was also a researcher. So, and I've noticed some misconceptions which are like really like hindering us from like, you know, be the best data person we can. So I'm gonna talk about those. So one of them, I think a lot of people think that you need to be a theoretical expert. And sadly, lots of interviews, when you apply for a data science job, still ask very theoretical questions. And you know, sometimes all you have to do in a data science job is linear regression and logistic regression over and over again. So it's very funny when they keep asking about how does support vector machine work deep down, you know? And so basically, this is a problem because conceptual understanding of basic models is still like a more useful mindset to have when you go into this, start into this field. The next one, some people think you need to be a programmer expert. Yesterday at dinner we talked about the hacker look of programmers. So it's really impossible to be good at everything, including becoming a computer science and a programmer expert these days. There are so many tools coming up, and if you really want to be an expert, you would actually have to be good at all of them. And honestly, if you focus on the basics and learn one programming language and learn some of the things from scratch, how they are working, how they are built, understand how things function and work together, then you can transfer these skills to other programming languages and grow from there. And so you don't need to be an expert. Other things people think is, we talked about the unicorn, right? You need to be excellent at programming, excellent at statistics. You really need to know all your linear algebra, like university grade level. You need to be expert at databases, be able to do SQL, be good at all of the visualization libraries, and know everything about industry, any kind of industry. I mean, just in case, you might need to be good at everything, right? So who feels like this has like this overwhelming feeling that we are facing these days about, it's not just in data science, but this need of becoming an expert at everything? It's really good to be good at one or two things and be aware that the other things exist and that they are important, so that you respect them and respect how you need to interact with the people that are good at those things. Okay, and again, it is fine to say you don't know something, but say there is enough evidence, I didn't know something, I had a problem, I figured out how to solve it. That should be enough, at least. Okay, another thing people think when they're learning data science is that you need to try, like you have a problem to solve and you need to try like 100 models. You know, something's gotta give. 100 data visualization, one of them is gonna look really good. And that's, yeah, well, this kind of work can really be replaced by like very fancy for loops, AutoML, and so on. So do not make yourself a replaceable algorithm. Yeah, so practice rather interpreting data, reading charts, be able to read charts. So it's more valuable to have a couple of models and really understand how they work rather than having 100 models and actually not understanding how any of them work. And the last thing people think that I've seen is that you also need to show that you know everything. And this is a problem because this is hardly ever necessary. Like if we would all like interact with each other by really always showing everything that we know, like the day won't be 24 hours won't be enough, right? So you need to show that you actually understand how to tackle a problem with one approach. You can like do baselines. So in data science, it's really important to like build up a baseline and compare to it and then build upon that. And also think about if you have a job interview and you start showing everything that you know and you're asked a question that the interviewer was like thinking you're going to answer in 2 minutes and then you spend 10 minutes answering, this is also like showing, like putting a red flag on you. So it's better to actually, if someone says, okay, so how would you improve this approach, to ask back and say, okay, what would be on what dimensions would you like me to focus? On speed, on accuracy, on performance, and so on, and then just go into one approach, right? And of course, if they want to hear all of them, but you're sure that they want that. So some people want to still get started with data science, get learning, yeah? So how do we do this? You have to be aware that I think at the moment data science is a profession really going through a refinement process, which software engineering went some, decades ago or so. So it's like a lot of companies are discovering that they really need data analytics rather than data science and so on. So it's getting really in this process where things are getting defined, what people want from it. So if you look at theory, you need to really know you really need to know statistics and probabilities, but really understand distributions. And you need to be quite good at, being able to do EDA, get your data, interpret it, clean the data, all of these things that people, those pie charts you've seen out there. Still, data cleaning is still like quite a big chunk of work. And sometimes you need to go in to be able to build an A/B test and like going in which requires you to know statistics, right? You don't really get around like knowing fundamental statistics. For machine learning, again, we are back to the basics are essentials. You want to really understand your basic models and know how they work and explain and be able to talk about. So linear regression, random forest, logistic regression, before rushing into be able to explain how a large language model works. Currently, what's really important in many jobs in data science is be able to assist with decision making, be able to, be able to infer based on the data, like what should be done. And most of the data in decision making is tabular data, which large language models still don't outperform XGBoost, for example. So think about like who is your audience for your job application, yeah? Tooling, of course, Python, or if you would like R or Julia or whatever. And of course, we all like Jupyter notebooks and we want to work in Jupyter notebooks, but if you are serious about 2023, there's more and more demand on software engineering for data scientists. So know how to work with Python besides the Jupyter notebook. Understand that you need to do testing, code reviews, like how do you work in the whole ecosystem, working in a team, and be effective at your visualizations. And another thing I think, which is really important if you think about it, data, it's always like a team that is a little bit like across a company, So no matter how, like each company goes through different ways of reorganizing structures and hierarchies and so on, but in the end, you really have data everywhere and data at like this and like that, and so data is really, as a discipline, is cross-functional. And no matter what you do and you will not really get ahead in your career if you do not practice your communication skills. You will need to be able to gather requirements and really understand what the stakeholder asks for you. You need to tell back to the stakeholder what you have achieved with those models that you build and so on. And sometimes you need to pitch a project to be given funding to work on, or to be given budget. It's called budget at work. So funding is in research and in a company with budget. And in order to pitch that, you really need to be able to pitch it, right, to get that. Okay, so how do you get started? So there, like these days, I think there's like a lot of options, and some of them will work for you and some will not. So you can do self-learning. I think for some people that works really well. You can do short programs like boot camps. That also works well for some, or long programs like get a degree. You can go back to university. There is no one recipe that is universal, so everybody will have to pick up one recipe or like a combination of them that works best for them. Okay, so what what have I noticed? That successful learners, so I'm not saying successful data scientists, successful learners, people that have successfully learned data science, what do they have in common? So most of them I've seen, they are resourceful, and they are strongly motivated. You have to be fine with not knowing everything and be of a mindset, if I don't know this, I can figure it out. Yeah, so the funny story is that when I was a child, I was, among others, so I once wanted to become a model, but then afterwards I thought I wanted to become a doctor. And then I said, oh, no, I will not become a doctor, because if you're a doctor, you have to learn your whole life. So I kind of became a data scientist, where, again, you have to learn your whole life, and you have to be willing to learn your whole life. So that is the profession, and if your mindset is a little bit like, oh, this is not my job, so I'm not going to do this, this is, again, not a very good team skill, right? You will want to prioritize teamwork. Yeah? As I was saying earlier, you as a person cannot be a unicorn. You should not try to become a unicorn unless you're a vampire. So I come from Romania, so vampires have very long lifespans, and they can learn everything that they want. You can have several degrees, you can have several PhDs, you can like stack. Has anybody here read the vampire book and knows what I'm talking? Okay, yeah. You're not a vampire, you're not a unicorn, but a team can be a unicorn. Yeah, so you can have in a team, different people have different skills, and together you can achieve stuff. And you need for that to kind of see value in other people's abilities that you don't have and you don't need to have, and you're like, oh, that's cool, somebody else knows that, so I know this, and we can complement each other. Okay. Another really hard skill that is really, it's a little bit hard to get, especially for people that come from academia to data science, and knowing when to stop and being able to stop. I mean, you can always do more analysis to really figure it out and like really find a better model and a better model. But in industry, most of the times you want something that is good enough for your stakeholder. So you need to be able to communicate with your stakeholder and give them the ability to let you know what is good enough for them, and you have to be able to accept that. To say, okay, in my first 2 weeks, I will focus on delivering this kind of value, and if that's fine, we can spend another 4 weeks afterwards improving that. But not going, I will need to have 6 to 12 weeks for doing the prototype. Because nobody wants that in industry, right? Like, you do not get a grant, nobody has time for this, especially in this day. So, and you need to be able to have that work for you, right? So sometimes this is really counter our perfectionism. Anybody here is a perfectionist? Good. So there's some perfectionists here. So this is really hard, right? When you're a perfectionist and you see that you could just a little bit like invest in it and to be fine with not doing that. And you can do it later, of course. Okay, and a really cool skill to have is, and important, is good technical writing skills. Who here doesn't like reading documentation? How about writing documentation? I said doesn't like. Yeah? Okay. That was a lot of hands. See, this is going out of this room, you know, especially if you're at the beginning of your career. If you're at the end of your career, nobody's going to, you know, they will find other qualities in you. But at the beginning of your career, not having this quality and skill is going to really, like, slow down your momentum in a teamwork, right? So you want to write documentation about the work that you did. You want to participate in code reviews, understand the whole way as a software team works, because data science teams do kind of work in a software engineering cycle. And I had a colleague, his name was Kayo, and he basically had a saying. He was not writing documentation for other people in the team. He was writing documentation for future Kayo. he knew that future Kayo is not going to remember anything that past Kayo did, right? Anybody who wrote code last week? Do you remember what it was about? Okay, do you remember? Some people are saying they don't remember what the code was about. Okay, so yeah, so we often think that our memory is like an elephant memory. I like to say, I think I have the memory of a bacteria and the attention span of a bacteria, and then be fine with that, and you just write for yourself, right? So you're gonna help yourself. There was also, yeah, at dinner yesterday, Nick was telling about someone naming their functions, doing something underscore A, doing something underscore B, and then they couldn't remember 20 years later what it's doing. Okay, so this conference is also about AI everywhere, and a large part about AI is large language models, right? So what role do I see that large language models play in the future of learning? I'm going to turn this a little bit around, and I will say, I think if you want to get into this field, you should definitely understand and work with large language models to understand how they're working, and to think, what are they good at, and what are they not good at? So don't focus at getting good at the skills that large language models are able to replace. Get good at getting good at those skills that large language models can't do. So, the human in the loop, if you want to be that human and not an algorithm in the loop, then be the human in the loop and focus on like, what can you do? What should you learn in order to, be needed, right? So think about it. I have an analogy for this: traveling, yeah? I don't know, some of us, so we said nobody's a vampire, but like if you remember, like long time ago, traveling was like going on foot, and then there was getting on carriage. Hamburg to Dubai would not have been 6 hours flight, it would have been way longer. Sure, we can take a flight, but as a human, in order to learn how to book your own flight and take a flight, you still need to go through learning how to walk as a baby, and then you learn how to ride a bike, and then you learn how to maybe drive a car. And then, anybody here has a flying license? Okay, so that would be like asking myself, anybody here is a large language model developer? Doesn't mean you can't use them, right? So this is like traveling, yeah? Learn the basics, and then you can use the advanced stuff. So, let's see the survey. What did we admire in our peers? Wait a second. Wait a second. Okay. So, Python programming beyond notebooks, data-driven decision-making mindset, and then runner-up, visualization and storytelling. So this is also comparable with what I ran this survey. I gave this talk last month in Hamburg, and it was also comparable with what people on the other side of the globe have to have as an opinion about what they admire in their data colleagues. Data-driven decision-making mindset. This is a skill that is like really a lot of experience gets you there, and like practicing that, because data-driven decision-making happens at any stage in a company. From deciding who to hire in many places to deciding what project to give a budget to, and so on, right? So it's not just, or what product to focus on, right? So it's not just about the product-facing users, but it's also internally in the company. We want to have data-driven decision-making and to be able to assist with that. So, okay, so this was in rainy Hamburg a month ago. You see, it's a little bit differently organized and skewed. So there was also here, I think, always start with a simple base model and being able to discuss their mistakes. Yeah, so that's again goes into team player mode and so on. Okay, so that was my talk. Thank you very much. This was
First of all, thank you for your great presentation. And I wanted to ask you about teamwork because it's one of my passions. And I had a lot of interviews with many countries, and most of them want us to say, to write them cover letters and all stuff. But one thing I understand from all these years, they don't care about it, maybe as we care about it, as developers who want to work in the industry, because I think teamwork is not just go to a team working with some people, it starts before we go to the company. And I think even the companies are mistaken about the meaning of teamwork. And when you said about teamwork, I wanted to know more about your opinion about the verb. I mean, what you think is teamwork is in this field, because right now I'm backend developer, but one of my passions is data science too, because we can use it a lot in software engineering too. And I wanted to know your opinion about it. Thank you.
okay. So the question was, how do I define teamwork? Yeah. Okay. Um, I guess being able to work with all sorts of different people, different skills, different disciplines, different cultures, different ways of working, right? Like it starts with some people work with Scrum, some people work with Kanban, and then you go to design and UX UI teams, and then they don't work with that, and it's really kind of, but you have to work with them and to collaborate on things, and then you realize we are like, how do we align on targets and so on, and so, and then also use tools for that, right, and workflows. So if I would see a CV, and you cannot just write in the CV, I'm good at teamwork, right? So you have to write things like, I have achieved this, and I worked collaboratively in a team, or collaboratively across a company, or all sorts of ways to write this. But then also, like, I'm able to do pull requests and work with code reviews in a collaborative way. So it's like all of this collaboration, and or say, like, I had a challenge in this project, but then my colleague was really good at it, so then we found a way to collaborate like that. So kind of, and then, just to add the and then part to this, job roles, when you apply, you will see that they have a lot of like this technical skills, but sometimes there's also like the non-technical skills. And those are like the things you can address in the job interview. Yeah.
Thank you. We have another question. Madam?
Hello, this is Sayeda Faiza from Pakistan. I'm a PhD candidate there. My question is, like, you have highlighted, we need to check how much we know and where to stop. As a PhD candidate, and because I'm from academy, I'm a lecturer there. So we just keep on checking the software and the tools and the loopholes, and we don't just deploy the product or deploy or use the services. But what the people in the industry do, they pick up some area, like with what you have said before, you just pick the product and you just tried and implemented it. So what is the good approach? What is the key point? What is the area where we as an academic, I need to stop and start using the product and stop checking for the loopholes or the issues? Because I'm more focused on, because my area is AI and machine learning. So I keep checking. I take too much time in digging the information and doing this all the KDD process and EDA and everything. So what is your idea? Okay, I need to stop here. I just don't need to. I need to consider this area as a supervise something, and don't need to check it, dig in hole and give more time to digging information.
Yeah. Thank you for the question. So I think the question is a little bit like how to kind of implement this knowing when to stop, like in practice, academia versus industry. You have to take I would recommend, because there is no like, here's the line, right? You take a step back and you think about who is the user who's going to use the product. And you as a data scientist really need to make sure that you understand what those people want. And as long as you don't feel like you understand what those people want, then you're not really in control of knowing when to stop. Because you can go anywhere, right? I mean, if your answer is people could want everything or anything, then it's really hard to, then you decide based on your experience, and maybe you don't feel like your experience is representative enough for all those users that you could have. So try to find out, and what we do when we teach data science in the boot camps, because sometimes you don't, as in a teaching environment, you don't have access to those stakeholders to ask them. So, okay, so you want this, and who's going to use it? How are they going to use it? And then what you do is you tell students to just invent some stuff. Just make the world a little bit smaller. Yeah.
Okay, thank you. Big round of applause, please.